The final section in Chapter 10 is Section 10.5, which is concerned with buffers. A buffer can be defined as a solution that resists change in pH when we add small amounts of acid or base. A good example of a buffer would be human blood. Buffers around about pH 7.4. The ocean, which is a little bit basic, buffers at around pH 8 or so. And then freshwater systems such as lakes and rivers, which tend to buffer at around pH 5 or so. Buffers are solutions typically that contain a weak acid and its conjugate base, or alternatively, a weak base and its conjugate acid. So here we have a weak acid, here we have its conjugate base. Here we have a weak base, here we have its conjugate acid. So here are a couple of examples of commonly used buffers that we will see in the lab. So we have a buffer that is composed of the weak acid acetic acid and its conjugate base, the acetate anion. And then we have another buffer here that is composed of the weak acid carbonic acid and its conjugate base, the bicarbonate anion. Note in each case that the acid has one more proton than its conjugate base. So why do buffers resist changes in pH? Well, it's pretty simple. Any acid that we add is consumed by the conjugate base. So here's our conjugate base of our weak acid acetic acid. Add an acid to it and it forms the acid acetic acid. Similarly, any base that we might add will be consumed by the acid that is present. So here we are, we're adding some hydroxide, that's from our base, and that's going to get consumed by our weak acid, which is acetic acid in this case, forming the acetate anion and water. So as long as our conjugate base and acid concentration are fairly high, then when we add small amounts of acid or base, the pH doesn't change. So here's an example from the book. The question reads, what solute combinations can make a buffer solution? Assume all are aqueous solutions. So we need to recognize a couple of things. A buffer is composed of either a weak acid with its conjugate base or a weak base with its conjugate acid. We also need to recognize that any ionic compounds will dissociate when they're dissolved in water to form ions. So we're going to have to be mindful of that as we work through these two examples. So in the first example, we have HCHO2, and this is the weak acid formic acid. And we can tell that it's an acid because it begins with hydrogen and it doesn't meet any of the criteria for being a strong acid. Now, the compound that it's being combined with is an ionic compound. So we want to consider what happens when this is dissolved in water. It's going to separate out into a cation and an anion. And so our question is, we've got a weak acid. Are any of these things the conjugate base of our weak acid? And a conjugate base, remember, has one less proton than our acid. And so, yeah, this guy is the conjugate base of our weak acid. So that pair will form a buffer because we have a weak acid and its conjugate base in the same solution. Now, in the second case, we have HCl with NaCl. And HCl, if we remember from earlier on, is a strong acid. And strong acids don't form buffers. So it doesn't matter anything about the properties of NaCl because we have a strong acid that cannot form a buffer. Okay, and that concludes chapter 10.